Welcome to Coffee and a Quickie, a short supplemental video for the Wireshark Network Analysis book. My name is Laura Chappell, and in this video, I'll be taking you through some of the book elements as I offer you some advice as you test your adapter. It's important to know the elements of the different adapters, such as will your adapter go into promiscuous mode? And what about in the wireless environment? Does it support monitor mode? Chapter 2 in the book explains the interfaces selection, and you'll see me selecting the interfaces, and I've got 4 options on my system. I'll show you what it's like when I start capturing to test what I can do with each one of those interfaces, and I'll show you one of the problems I have for one of my systems whenever I try to capture off of the native wireless adapter. Let's begin by the first term that you need to know when you're capturing traffic. Promiscuous mode. When you capture traffic with Wireshark, by default, promiscuous mode is turned on. A driver and a card that can go into promiscuous mode can capture traffic that is not addressed to that local card's hardware address. It can listen to traffic addressed to anyone's hardware address. So most of the time we want to have promiscuous mode on, and that enables us to listen in on Fred's traffic traveling to the server as long as that traffic is coming down our port, perhaps from a full duplex tap or from perhaps a spanned switch port. So let's begin by capturing some traffic on my wired network interface card. For this recording, I'm using Wireshark version 1.2.6. And on the left-hand side, you can see we have the capture area on the start page. These are the 4 interfaces that Wireshark recognizes on my system. I have an Air PCAP adapter. I also have a Microsoft adapter listed, which is my native wireless adapter. The one on the very bottom there is my wired interface. If you select the very first button on the toolbar, you can see the interface list, and you can tell which interfaces are currently most active. We'll talk about wireless capture in just a moment, but I'll start with this wired Ethernet card right here. I'll just click Start. There's not much going on the wired network because we're using wireless for most everything that we're doing in here. But as we just start capturing the traffic, no error message should come up. You shouldn't see any sort of an error message come up. And if you are using your wired network, you should be able to see some traffic. You can see that we've got some systems in here that don't even have assigned IP addresses, but at least I can see, okay, I can capture some traffic. That's great. I'll go ahead and stop capturing at this point. And now I want to take you over to the options area and what your choices are when you're going to capture. The second button over shows you the capture options. Here's the capture options window, and you can see that by default, capture packets in promiscuous mode is on. You can also see that you have a choice to capture just any packets you want or apply a specific capture filter. Maybe I'm interested only in IP traffic. I can apply that as a capture filter in this window. In addition, I can choose if I want to capture to a file. So I put in a file name here, or I browse to a specific path and place the file name and the path up here. I can choose to capture to multiple files. So if you're capturing a lot of traffic, you don't want to capture just one huge monster file. You want to probably break that up. So in this case, I want to break this up into files, and I want the next file to be created after 50 megabytes of traffic have been seen, or after 5 minutes, whichever one occurs first. In addition, I'm going to say that I want to stop capturing after 10 files have been created, but I only want to save the last 2. You can also define some stop capture criteria down below based on the number of packets, the number of megs, gigs, or kilobytes that you've captured, and after a certain amount of time. I'm just going to go from the start page, and I'm going to capture traffic on my native wireless adapter. So this is my native wireless adapter. The second one is just listed as Microsoft, and I'll click on that. And it goes ahead and it starts to capture, and I don't have any filters applied. I don't have any stop criteria defined. I'm not using a ring buffer or anything. It's just capturing it and showing me what it sees. And there we can see I'm capturing traffic. We can see my packet list counter going up. But if you look at any of these packets in here, notice in the middle window it shows me that I have an Ethernet 2 header on these packets. Well, that's impossible. These are 802.11 packets. I should have an 802.11 header showing up in these packets. But that adapter is stripping off the 802.11 header and then passing it up. And Wireshark just puts on an Ethernet 2 header just to make me feel happy and comfortable, because I know that there's got to be some MAC layer header there. This is the reason we get specialized adapters like the Air PCAP adapter, because that one will pass up to us the true 802.11 header. But at least I can do some troubleshooting. I can see that, man, this printer is really, really chatty on the network. I hate that kind of stuff. So I can do some level of troubleshooting. Notice that I have a channel column that I've created here and a signal strength column. I'm working in a profile that I've created for wireless LAN traffic. And these columns are blank because capturing from my native adapter, I don't have that information to put in there. So let's stop capturing, and I'll go back to the Start window. And now I'm going to choose to capture from my Air PCAP adapter. So I'll click on that adapter, and things look quite different. You'll see, first of all, I've got color coding in there based on the channel that the traffic is flowing over and some other elements of the wireless traffic. And again, Chapter 26 is the Introduction to Wireless LAN Analysis chapter, so you might want to take a look at that chapter if you're going to be working in the wireless environment. Here we can see when I look at any one of these packets, I've got a radio tap header that I've chosen to apply, and then right after that there's my 802.11 packet. Now notice that we didn't see any of these management frames when I used my native adapter. All of that stuff is invisible to me using the native adapter. I have to use a specialized adapter that will pass all of this information up. So I'll be able to see the data frames. Okay, there's a data frame right there, and there's some data. But I get to see the 802.11 header structure, and I get to see all the management frames as well. Now I want to show you what it looks like when I work on another one of my systems, and I want to use the native wireless adapter to capture traffic. I have problems with it because it doesn't support promiscuous mode. In this particular situation, I'm working with the development version of Wireshark. We can see that I have 3 adapters listed here. And the bottom adapter is my wireless adapter. So I would just like to capture on that. But when I do, it gives me this screen that says that there's a problem. The capture session could not be initiated because the hardware failed to go into promiscuous mode. So I need to go into the capture options area, and I'm going to disable capture packets in promiscuous mode for that wireless card. Now I can go ahead and click Start, and you'll see that now I can capture packets. Now we can't do wireless LAN analysis without talking a little bit about monitor mode. Monitor mode isn't the same as promiscuous mode. With promiscuous mode, we're talking about listening to the traffic and allowing the adapter to pass up traffic that isn't addressed to the local MAC address. That way we can listen in on other people's traffic. But in the wireless environment, we also want to have monitor mode enabled. Monitor mode basically sets the adapter so it doesn't join any service set. And now we can listen in on all of the wireless traffic, not just the wireless traffic of our own wireless network. So in an ideal situation, we would have an adapter, such as my Air PCAP adapter, that listens into the traffic in promiscuous mode and monitor mode. And it passes up not only the data packets, but also all of the management frames that we see in 802.11 traffic. I want you to pay attention to Chapter 26 and the capture table that I created there, because that talks about the different variations of what adapters can handle, promiscuous mode versus monitor mode, and what you can do to get the most out of the adapter connected to your system. So now's a great time to start capturing your traffic. Go ahead, go forth and capture.